Hello and welcome to this video on installing NVIDIA Virtual GPU technology on Windows Server 2025. Now we have supported running vGPU on Windows Server for some time with the Azure Stack or Azure Local technology, but this will be the first time that we've actually supported this technology on the standalone Windows Server 2025 product. You'll need to have Virtual GPU 18, which is where we started supporting Windows Server 2025 and GPU Partitioning, which is Microsoft's name for vGPU. Okay, so we have a Windows Server 25 up and running. Let's just go ahead and install the prerequisites for vGPU and virtualization. So the first thing we're going to need to do is install Hyper-V, of course. So let's just go through the Hyper-V installation, choose all the defaults in here, give it a location to put our virtual machine disks and click install. And in a couple of minutes we'll have Hyper-V installed on here for virtualization. Now, the next thing I'm going to do is I'm going to install Windows Admin Center, and all of the administration I'm going to be doing today will be using Windows Admin Center. Now, you can do most of your vGPU administration using PowerShell commands, but I'm just going to go through in here and install Admin Center, accept all the defaults within here. A few things like Express or Custom Setup. I'm going to choose the 60-day key because just in a demo environment here, accept all the rest of the defaults, and we're going to be up and running with Windows Admin Center. I'll be giving you those PowerShell commands as well, by the way, as we're using Admin Center, in case you would rather use PowerShell to configure the virtual GPU solution. So next thing we're going to do is we're going to log into Windows Admin Center, and we're just going to have to do some configuration in here before we start. So we're going to select the server here. And there's a little icon when this is connected up in the top right hand corner here, and we're going to click on the setup icon in the top here. Within there we have something called extensions, and what we're going to need to do is install the GPU extension in here so that we can manage the GPUs that this server has. Hit the install button, and within a few seconds it'll automatically download and install the GPU extension. You can see in here installed extensions GPU. So in order to install vGPU, we need to go to the NVIDIA licensing portal and go to software downloads and download the package for vGPU. So I'm going to just do a search here, vGPU Windows 2025, and always choose the latest package that we have listed here. At the moment we have 18.0, we have 18.1 and 18.2 as well, by the way, since I recorded this footage. Just double check here, you're going to need at least version 3.4 of the DLS if you're running vGPU 18. That's just something that's a vGPU 18 prerequisite. And once we've done that and had a look inside the zip file, we'll see here the downloads for the virtual machine drivers and the server drivers. I'm just going to copy that Windows Server host directory down to the local machine, my local Windows Server 2025 screen. Okay, so just create a directory there, vGPU, and copy those files in here. Now what I need to do next is drop to a command line, and we can actually see here that we can install the virtual GPU manager software within the Hyper-V host. So let's just go to that directory that we created and put those files in, and type in the command to install. There we go, there's our display drivers. Let's type the command now to install our vGPU software. We use the pnputil.exe/add driver, give it the inf file for the software, and look in subdirectories and install. And in a few seconds you'll see it'll ingest that software, and we'll have the virtual GPU software installed and running on our host. We're just going to do a quick reboot just to make sure that that's installed. Once it's rebooted though, just notice that when I installed Hyper-V and rebooted the server, it went from having a static IP address back to having a DHCP address for some reason. So I just went in here and re-edited and gave it a static IP address. I don't know if you're going to come across that, but if you do, that was a little funny I saw during the installation. I think it was to do with Hyper-V install that turned it back. Now you'll see within display adapters here now that our L40s are now both listed. We have two L40s in this machine. Okay. Also, if we type the NVIDIA SMI command, like we can do on other hypervisors, you'll see that the two L40s are listed there and ready for virtualization. Now, if we want to take a quick look and just actually see what GPUs are supported here, we've got L40s as you see. We can just very simply go down into the INF file that we installed just now and just have a quick look inside that file with Notepad. We can just do a search for the string of L40, for instance, because we suspect that L40 is supported in this release. But what you'll also see in that section where L40 is listed are the other adapters that we support with this technology. As you can see, Ada Lovelace and Ampere technology. Now, one of the things you need to do in Microsoft Windows 2025 is you need to tell it what types of profile, what licenses you're going to be using. So we need to modify the registry with a license type you're going to be using, whether it's virtual PC, virtual workstation, etc. And to do that, what we need to do is go to the GPUs and look at the driver key, which will give us the area in the registry that we need to modify if we need to. Okay, so we're just going to go for our two GPUs here, our two L40s, and actually have a look to see where those settings are held in the registry. Go down to driver key, just copy those two parameters there, and we can search for those in the registry in a few seconds. Okay, as you can see, they both have the same ID with 0002 and 0003 after them. Now, if we go into the registry, what we need to do is find the area where that license type is defined. Okay, so let's do a search. And what we're going to do is search for the license type command, which is grid GPU profile type, okay, and find next. Now you're going to find a couple of references to this in here. For instance, we have, control set 1. If we look in here, there'll be control set 2 as well. I would ignore control set 1 and control set 2 altogether. These are just the boot profiles of the server. What I'd look for is current control set and actually put my parameters in here. So if you look, you've got the ID that we searched for earlier on and we recorded. You'll see there's 0002 and 0003. And there's a feature in here, grid GPU profile type. Okay, and we can see on both GPUs it's actually set to 1 at the moment. Now, it depends on what license you're using as to which profile type you're going to need. 1 is for virtual workstation, 2 is for virtual apps, and 3 is for B series profiles, so virtual PC profiles. Okay, so set that accordingly. Okay, so now that we've installed the vGPU manager onto our server, let's take a look at the profile sizes that we're going to be allocating to our virtual machines. So to create our GPU partitions, let's go into Windows Admin Center and let's click down on that GPU extension that we installed earlier on. And as you can see here, our two L40s are listed within here. Now, in order to do this, we need to go to GPU Partitions and we need to define how many VMs we're going to have on each of these GPUs. So we'll configure what's known as the partition count. Okay, so bear in mind that this is temporal partitioning. This is time slicing, not physical GPU partitioning that we're doing here. So in this case, let's just choose 12 VMs maximum on this L40. Okay, so each one can have up to 4 gig of RAM. Maybe we want to purpose our other GPU to a different workload. So let's go to our other L40 here. And in this case, we're going to choose 24 virtual machines. So 24 VMs, 48 gig of RAM, so they will get 2 gig partitions each. Now, don't worry about that 1.95 there, by the way. They will actually get 2 gig partitions. So once that's done, it takes a couple of seconds for Windows Admin Center to catch up with you. If we just hit a refresh, you'll see there that we have our partition schemes configured now. If we just want to look in PowerShell, now we gave you the PowerShell command for doing that, but let's just go in and within PowerShell run the command get VM host partitionable GPU and actually have a look to make sure that that's been set correctly on those GPUs. You can see there one of the GPUs has 4 gig partitions available on it to run. If we go up to the other GPU, you'll see there are 2 gig partitions to run. Okay, so those configurations have taken successfully and we're ready to go on to the next step. So let's just go ahead and, using the Hyper-V Manager here, install a couple of virtual machines. First one we're going to create is a Windows 10 virtual machine. I would have installed Windows 11, but I didn't have a TPM in my server. You always use generation 2 or above hardware is what we'd recommend here. Go through, give it memory, give it a NIC, give it a hard drive, and just go ahead and create that virtual machine and install the operating system as you would do normally. We're going to do the same here as well. I'm going to install an Ubuntu VM so I can show you the Linux install. And once we've installed those operating systems and patched them up to the latest level, we'll just have a couple of operating systems that are running that we can install our virtual GPU drivers into. So next thing we need to do is, when the VMs are actually turned off, is just go in here and allocate them GPU profiles, or GPU partitions as Microsoft calls them. So we're going to assign a partition here, choose the local server, choose which virtual machine. In this case we're going to choose first our Windows 10 VM, and I'm going to select for this particular VM one of our 2 partitioning schemes, which is the 2 GB partitioning scheme, and we can assign this partition. I'm going to go through exactly the same process for our Ubuntu VM. This time though, instead of choosing the 2 GB partition, I'm going to choose a 4 GB partition. So Ubuntu, VRAM options here, give it a 4 GB partition, time sliced partition. Hit assign partition, and we're now ready to go. Okay, so now that we've configured our GPU partitions, all we need to do is we need to power on our virtual machines, and we can continue from here. Okay, so now that we've created a few virtual machines and allocated vGPU profiles to them, let's take a look at installing the drivers within our virtual machines. So let's start off with our Windows VM, which we've booted and connected to via RDP. So what you'll see is we've installed we've copied down a couple of things. The driver from the driver package that we downloaded earlier, and we've had the client configuration token from the license server copied down. You'll notice at the moment, display adapter wise, it doesn't list any GPUs at all. That's because we haven't installed the driver yet, of course. The GPU is actually there in the background. So let's just run the driver installation package. Make sure that you use the driver installation package from the same package as you downloaded the vGPU or installed the vGPU software for on the server. Okay, it's always good to have a matching pair. We'll just go through and specify the standard installation here. This is going to take you a couple of minutes, but once that's done, we'll be good to go. As you can see now, we have an L42Q profile listed there, which is what we would have expected after we installed our driver. That's the partition that we assigned. Next thing I'm going to do is take that client configuration token and put it into the correct directory. So when the driver loads on a reboot, it will actually pick up the NVIDIA license from the NVIDIA license server. That's got to go in the client configuration token directory here, just paste it in there, and we're good to go. Now normally when a VM reboots, it'll automatically get a license using this token, but I'm just going to force that in this particular case to save us having to reboot the VM. So I'll go into the services, we'll go to the NVIDIA display container LS service and just restart that service. What that will do is it will force a reload of the license file. Give it a few seconds. As you can see, it's coming up in the corner there with acquiring NVIDIA license. And as you can see, it's gone to the license server and pulled down that license for a lease time of 24 hours. Now there's a few places that we can verify that the licensing was done correctly. The first one is our control panel. So if we go into manage licensing here, you can see that we've now got a license. Your system is licensed for RTX Virtual Workstation. We can also check for it in using the NVIDIA SMI command. Now always check that your licensing is correct, because we will throttle performance in virtual machines if they don't have licenses. Okay, after 20 minutes we'll throttle it, and after 24 hours we'll throttle it even further. Now if we scroll down here, you'll see here it'll list we have a virtual workstation, RTX Virtual Workstation, and we're licensed, and the lease expires in a day's time, which is a standard lease, which gets automatically renewed from the license server after 24 hours. Of course, we can type NVIDIA SMI and see the GPU in there. Now, another thing we can do is we can go in and check the logs for licensing. So if we go into this directory here, you'll see this is the license server log. Initially, we didn't have a license and it failed to acquire a license. But you can see here, after we copied the file into the right place, it actually came up and got a license. One of the common things we see with licensing is that the time is different between the license server and the VM. So always make sure that your license server is within 5 minutes either way of your VM's time, because it does matter. Now, if we go into Task Manager here, we'll see that you can see the GPU. And if we just use a browser just to generate a little bit of traffic on the GPU, a little bit of graphics traffic, you'll see the 3D engine there on the GPU is now ticking away nicely. So we know that our GPU is actually rendering graphics for us. Okay, so let's move along to our Linux VM, and I'm just installed OpenSSH into my VM and just connected via PuTTY to an SSH session in here. Now let's just have a look and see if the GPU has been recognized within here. As you can see, the L40 has. Now, one of the things with having a GPU installed but no GPU driver is that Linux will automatically install the Nouveau driver for you, the open source GPU driver. And that's something that we actually don't want inside this VM. So the first thing we need to do is just blacklist that driver so that it won't actually load the next time we boot this virtual machine. There's a couple of parameters we need to put into this blacklist file. And once we've done that, Control O to save that file out and Control X to exit, and then just reboot that virtual machine. We can reconnect to that session after a reboot and just double check to see if that driver's loaded. Run the same command again to see if Nouveau's loaded. And in this particular case, you'll see that there is nothing being returned. So we're good to go. Nouveau has been disabled. Now, another thing to do before we install our driver is a good idea to just do a quick update of the Ubuntu operating system before we carry on. As you can see, everything is up to date. Now, next thing we need to do is just copy the install driver file down to that VM. So let's just use the deb package there. I'm going to put it into the TMP directory off root. The reason I did this is because I tried to install this from my home directory, but there were a few file access errors at the end. So just to be safe, I've just copied it down into the TMP directory. We're also going to copy down our client configuration token in here as well for licensing the virtual machine afterwards. Let's just go into that temporary directory, do a quick file listing. As you can see, there's our install file and there's our token, and we can carry on forward. So let's just install the driver using a sudo apt-get install and then point it at that deb file, and it'll go through. It'll ask us a few questions. We're not going to have it here, but if you're using Secure Boot, it will ask you about a machine owner key, and you'll need to allocate a password for Secure Boot that you need to verify when you reboot your virtual machine for the first time. We don't have a machine owner key or mock key here, so it hasn't done that. Once we've installed that driver, we should find that we're all up and running. Let's just copy that client configuration token to the right place, which is etc/nvidia/client config token, and we should be good to go. Let's just restart this service, the NVIDIA Grid D service, which will do the same as what we did on Windows. It'll restart the service and consume a license from our license server. Just click NVIDIA-SMI. As you can see, it's all up and running. We have our L44Q profile in there as we defined in our partitioning scheme earlier on. What we can also do is use NVIDIA SMI with the -Q parameter and just check that the licenses have been acquired. As you can see, licensed, expiry 1 day's time. It'll automatically renew just the same way as it would do in a Windows operating system. Now, another thing we can do is just to verify licensing is to go into the log file. So go to var log and then the syslog on Ubuntu here. And if we look in there and look for instances of the NVIDIA Grid D service, we'll actually see those licensing transactions happening. So you can see NVIDIA Grid D, NLS initialized, acquired license, license successfully acquired. Okay, so everything's good within this virtual machine, and we're now ready to go. Okay, so I just wanted to give you a little bonus feature, if you like, in this video. Now, one of the interesting things about Windows Server 2025 is it supports both nested virtualization and vGPU inside the same virtual machine, which is something that other hypervisors don't do at the moment. Now, with nested virtualization, what you can do is it opens up technologies such as Credential Guard, for instance, such as Windows Subsystem for Linux to be run inside these virtual machines. Now, we have a technology called AI Workbench, NVIDIA AI Workbench, and it uses Windows Subsystem for Linux underneath it to actually run containers and services for AI development. So let's just show you how to set that up. So for the first part of this bonus section, we'll just show you how to enable nested virtualization in our virtual machines. As I say, something that is unique to Windows Server 2025 and vGPU at the moment. Go into the Windows VM that I have here. In this case, I have a Windows 11 virtual machine running on this hypervisor. Go into Processors, and you'll see there Enable Nested Virtualization is actually ticked. Now, sometimes I've ticked this box and it hasn't actually done it. So what I'd recommend at this moment in time is just to double check, use the PowerShell command to enable nested virtualization. So get-vm will get you the name of the virtual machine we've got. We then need to set VM processor, VM name, and then expose virtualization extensions true, okay? And that will do exactly the same as tick that box in there, but just to verify that it's done within there at PowerShell level first. What we can then do is we can get our virtual machine up and running, we can boot it. We just need to go into core isolation here, the core isolation settings within here, and just enable memory integrity within here and reboot our virtual machine. And with those two things set up, what we will see when we reboot the VM is if we go into a command prompt and we just type system info, you'll actually see that we've got it installed. So you can see VBS, virtualization security, nested virtualization enabled. We've got Credential Guard active. That's all ready to go. Now what I'm going to do is I've just installed AI Workbench into this virtual machine. It's the same VM on a different day, okay? And if we load AI Workbench, what that's going to do is it's going to use Windows Subsystem for Linux to actually run containers on this virtual machine under Windows, okay? So when we launch this project here, Agentic RAG is the project that I've already cloned here. What it's going to do is it's going to launch some Docker containers within Windows Subsystem for Linux, which uses virtualization-based security. If we go into Open Chat here, this will open the chat interface for our Agentic RAG. I've set it up to use the NVIDIA endpoints in our NGC, NVIDIA GPU Cloud. So I can just come in here and use this chat application now. It has a RAG backend and a vector database and all that stuff installed in this particular project on Windows Subsystem for Linux. If I just enter a question like tell me about NVIDIA, for instance, then the API endpoint in the cloud will come back with an answer for me. As you can see, NVIDIA is a technology company, etc. And if we go in here, we can see it's recognized this particular VM's got an A4024Q profile running in it. So you could run some small large language models or some quantized large language models, even locally within this machine. Okay, so now you have a fully loaded AI development workstation running NVIDIA AI Workbench. I hope you enjoyed this video and good luck with your project.